Diving rudders have completely seized up. Sometimes I think this sub will never be ready for launch. Where is the oil? Oh, great. Another scientific investigation. What's going on?
Stella, we're having another argument here. Gemma says the drink is totally pure.
Yes, it's pure orange juice. It says so on the bottle. It's made from real oranges.
It's got bits in it. It's not really pure. My mineral water's totally clear and clean. There's nothing mixed in it, and it comes from the mountains. It must be pure.
It's had chemicals added to it to make it clean. You can talk. Your cola's fizzy and has artificial flavouring. Stella, what do you think?
Well, I can settle one thing straight away. They're all full of chemicals. Chemicals aren't just things you find in labs. Everything around you is made up of chemicals. This cake is made from all these ingredients.
But what are the ingredients made out of? They're all made out of chemicals called elements. Elements are the building blocks of everything around us.
This lot certainly don't look very tasty. In fact, some of these elements are toxic and dangerous. When elements combine, they produce something that looks and behaves very differently from the raw ingredients. Now, what do you think this little group of elements makes up? My sea chest and compass. My book of navigation charts. Or my trusty cat, Boffin.
Actually, it's Boffin. Even living things are made up of elements. Everything looks so different from the raw ingredients, the elements, because of the way elements are combined together. Elements are made up of tiny particles, too small to see with the naked eye. Particles of one element are all the same. Imagine these are particles of the element sodium. Chlorine particles are very different from sodium particles. But when particles of different elements get together, two things can happen. They can be mixed together, but they keep their own characteristics and are easily separated. Or they can join together chemically. They're much harder to separate now. The chemical combination is called a compound. The elements sodium metal and chlorine gas combine together to make the compound sodium chloride.
Sodium and chlorine are just two of the 112 elements discovered so far. Most of these, including sodium, are metals.
Iron, lead, copper, tin, aluminium. You can see them everywhere, but often metals are much harder to spot. They're in disguise as compounds.
All iron on Earth starts off like this and often ends up like this. Neither this rock nor this rust look like metals at all, but they both contain iron combined with oxygen to make the compound iron oxide.
But a few metals can be found in a pure state naturally on Earth, including the most precious metal in the world. And Femi's out to get some.
The Welsh gold in these hills near Dolgellau was first discovered over 150 years ago. The Victorian miners tunnelled into the hills in the hope of great riches.
150 years ago. You guys must have had the longest tea break in history.
Excuse me. Hello, Femi. I'm Roland. I'm in charge of the mine today.
So you're still finding gold here today?
Yes, that's right. Though we have to go deeper to find the gold. The Victorians worked all these upper levels.
Let's go.
Let's go.
Today, tourists can visit this part of the mine, but Roland is taking me deeper underground.
Gentlemen first.
As the years pass, the miners have to tunnel deeper and deeper to find new veins of rock containing gold.
This white vein is where the gold is found.
Oh, yes, I think I can see it. Little specks of gold just sparkling.
No, sorry, Femi. That's a mineral called pyrite, commonly called fool's gold. Although there is gold in this rock, it's mixed with other minerals such as quartz or lead.
So how can it be pure gold if it's mixed with all those things?
Although it's a mixture, it's not chemically combined, and that means that it's easier to separate.
But first, it's down to me to collect some samples. None of them look very special, but Roland's expert eye can pick out the real gold from the fool's gold. The streaks in these samples are pure Welsh gold.
Perhaps we could take these to the mill.
Okay.
The next job is to separate the gold. First, the rock is crushed into fine particles and mixed with water. This shaking table completes the job. The motion separates the large light lumps of minerals from the small heavy particles of gold. Look at the stripes of minerals forming on the table, and the narrow sparkly band at the very edge. That's the gold. It's such a simple process and has changed little over the years because the gold is just mixed with the minerals. It's the moment to make my escape. I've got a funny feeling I'm being watched.
Not so fast, Femi. We've another stage yet to do. We have to take it to the smelter.
The final stage is to melt down my gold flake in the smelter.
Wow, pure gold. It's gorgeous. So how much is the gold we found today worth?
Well, we make it into very special jewellery, so there's probably a couple of £1,000s worth there.
I've only got about a fiver.
Well, that'll get you this very nice piece of Welsh gold ore.
Thanks, Roland.
Pure gold may be hard to find, but it's easy to separate once you've found it, because it's just mixed with other substances. Most metals found naturally on Earth are chemically combined with oxygen as compounds, and separating them is much harder.
This yellow powder is lead oxide. It looks nothing like the metal lead, does it? It's impossible to separate the lead from the oxygen by sieving or shaking. Instead, I need to heat it with carbon, the black powder, to produce a chemical reaction. Eventually, it releases tiny drops of molten metal, pure lead. Here's a very familiar compound, water. This apparatus uses electricity to release the elements which make up water. Bubbles of gas are released from two electrodes, oxygen bubbles from this one, and big hydrogen bubbles from here. The oxygen and hydrogen collect in the top of the tubes. But look, there's twice as much hydrogen as oxygen. Why? When particles join together in a compound, they cling together very firmly. The combinations are called molecules. The particles can only join together in specific combinations. In water's case, it's 2 hydrogen particles for every 1 oxygen particle. No extras are allowed. All molecules in a compound are the same.
Hydrogen, oxygen, sodium, chlorine, gold, lead, copper, tin. How many elements did you say there were on Earth? Aluminium. 112. That's not many. I bet there's thousands of elements in space.
Phosphorus?
Yeah, thousands.
Millions of different and strange elements out there.
It may seem strange, but scientists believe exactly the same elements are the building blocks everywhere in the universe. But how do they know? I think Femi should find out more.
Every year, more than 40,000 tons of rock come crashing down to Earth from space. Pieces of asteroids, pieces of the moon, even pieces of Mars. They're all called meteorites and have travelled millions of miles through space and end up here on Earth. Thanks, Alec. This masonry, courtesy of Alec, hasn't had quite such a long journey. But in this building, some rather more interesting specimens. Every year, the Natural History Museum receives samples of meteorites from all over the world for analysis. Finding out exactly what meteorites are made of can tell us a lot about where they come from. We can discover exactly what elements and compounds are up in space without having to travel there.
I've come to meet the person in charge of analysing meteorites.
Monica, they just look like rocks from my back garden. What makes them special?
Rocks from space often do look like rocks on the Earth, but actually they are very different. The elements, the building blocks of rocks, they're the same in meteorites as they are on Earth.
So, like oxygen, iron, gold?
That's right, exactly. But it's the proportions of the elements and the way they're combined into compounds that's different in meteorites. And also, some of the elements you actually find in their pure form in meteorites, where you don't ever find in their pure form on Earth.
Wow, look at that. It's all shiny. In fact, it looks like metal.
That's because it is metal.
I've got a little test for Monica. Now, I've collected 3 rock samples. One is a lump of sandstone from the Lake District. Another is my sample of Welsh gold ore, fool's gold. That should keep her guessing. And the last one has travelled millions of miles in space. It's a meteorite from the asteroid belt.
10 minutes are all she's got to find out which one's the meteorite.
So, Monica, time's up. What do you think?
I think you found this one in your back garden. I think this is a sandstone. It's a reddish colour where the iron in it has been oxidised. It's completely non-magnetic.
Absolutely.
I think you were trying to fool me with this one. Fool me with your fool's gold. This is the iron pyrite from the Welsh Hills. Again, completely non-magnetic. But look at this one. This is the meteorite. It's the pure metal. It's made of iron. It's magnetic. And it's very heavy. This has come from the asteroid belt.
Well, Monica, not bad at all. In fact, you're officially science in action. Brilliant.
Thank you.
Everything is made up of elements, either mixed together or combined as compounds. But what does that tell us about how pure something is?
I hope this ethanol is pure. It won't run on anything else. In scientific terms, pure means something very precise. I've sent Femi out to find the purest drink she can.
I come to Buxton. What better place to find a pure drink of water? It's the source of a natural mineral water. But is the water really pure? Well, the locals think it is.
Well, I think it's good stuff. It's nice.
Very good, very pure.
Interesting. When people talk about purity, they use words like natural, clean and good. But in science, pure is something very different.
I'm going to find out if this mineral water is scientifically pure. The water's found under the Derbyshire Hills, and that's where my investigation starts, with cave expert Alan Walker.
Well, caves can help us by giving us clues about what's in the local water.
Yeah, but even with this torch, all I can see are stalactites.
That's clue number one. Stalactites are formed by dripping water over thousands of years. The drip of water dries up and leaves behind tiny crystals of calcium carbonate.
Calcium carbonate, a compound. Ah, so already we know that the local water must contain calcium.
And the band of orange on the wall indicates that there's iron in the water that's passed over this area.
So that could be in the water too?
Correct.
Alan showed me examples of other substances like manganese left behind by the water. It looks like there could be much more than just the elements hydrogen and oxygen in the local water.
This is the lab where the local water is tested, and Karen here does the testing. Can you help me out here? I'm a little bit confused. The locals call this water pure, the leaflets call this water pure, even the bottle claims it's pure, and yet it looks likely that it does actually contain calcium, iron and manganese.
Yes, you're right to be confused. That's because the everyday use of the word pure is somewhat very different to the scientific use of the word pure. This sample of water is actually a mixture of water and all of those minerals that you mentioned earlier. And mixtures are never pure. That's because what they contain can vary. Pure water contains entirely the elements hydrogen and oxygen.
So where can I find pure water then? Scientifically pure, I mean.
Well, if we take this sample of water for starters, I'll show you what we can do.
Karen heats up the mineral water till it starts to boil. The minerals in the water can't boil off, but the pure water can. The pure water vapour passes up through this tube. The tube is kept very cool, so the water vapour condenses and water trickles out the end. Scientifically pure water. But when all the water's boiled away, what's left in the flask?
So how did you get on, Karen?
Well, these are the minerals that are actually in your sample of water.
You can clearly see traces of minerals left behind on the side of the flask.
So scientifically, the mineral water is no more pure than my fizzy drinks.
Indeed, they're mixtures too.
But that is pure water.
Yes, this is pure water. It's actually tasteless, and it's the minerals that give the water its unique taste.
I think I'll stick to the natural, but not scientifically pure, Buxton water. Cheers.
Better smarten up these handles before I go. Now, these are obviously made out of metal, brass. Brass and bronze are quite common metals, but are they elements?
If they're metals, they must be elements. No, lots of elements are metals, but not all metals are elements.
So some metals are compounds?
No, it's a special sort of mixture called an alloy. So what's bronze then? It's an alloy of copper and tin.
So brass is an alloy too?
Yeah, it's copper and zinc, I think.